Hello friends, in this video I'm going to conclude my works on latitude and longitude by discussing the shortest distance between 2 points. Okay, if you are following my works on latitude and longitude, you understand how to make a sketch and locate points on the Earth's surface. Before we go into the shortest distance between these 2 points, let us first of all draw the Earth and locate these 2 points. Now, okay, so this is the Earth, where here is the North Pole, here is the South, here is West, and here is the East. This is the equator, which is a greater circle. This is the meridian. Now, if I want to locate these 2 points, A and B, on the Earth's surface, it is on latitude 30 degrees north, and north is up here, so it's not going to come down, it's going to be at the top. So, and from the center here is 0 till 90 degrees. So I can choose any convenient points between 0 and 90 and call it 30 degrees. So let me assume that this is the point, which is 30 degrees, a latitude. Okay, so this is a point 30 degrees, which is a latitude. So I will call this particular point 30 degrees north, and it is common for both of them. They are on the same latitude. Now for A is at longitude of 40 degrees. East, look at this side is east. So let me assume that this particular line is at 40 degrees. So I will call it 40 degrees east. The point of intersection of latitude and longitude will give us the point we are looking for. And look at the latitude here, while here is the longitude, and they met at this particular point. So here can be called point A. Now for point B, the same 30 which we have marked, but it's on west, which is 35 degrees. So let us assume that this particular point is at 35 degrees, or let us increase a bit because 35 should be more than 30. So let's say that this point is 35 degrees, 35 degrees west. Okay, so the point of intersection of this 35 degrees and this latitude we have drawn will give us point B. Okay, so now we can now get their radius. For point B to the center, look at the center here. Point A to the center, look at the center here. You will now see that a shape like this is generated, a shape that looks like this, where here is point B and here is now point A. The total angle there, like from the earlier discussion, I told you that when they are from different points, we are going to add up. This is 35 west and this is 40 east. So the theta we are looking for will be 40 degrees plus 35 degrees, which is now 75 degrees. So our theta is 75 degrees. Then our alpha is the latitude, the common latitude. So alpha is now 30 degrees. Now, assuming the question says distance between A and B, it means that you are now going to use the length of arc. The length of arc. And length of arc of a circle is theta over 360 times 2 pi r, small r, because this is a parallel of latitude, a small circle, not from the greater circle. But remember, I told you in my previous videos that r is equivalent to r cos alpha. Therefore, here I'm seeing small r, I will remove it and put r cos alpha. Hence, the distance is now theta over 360 times 2 pi. Seeing small r, I will now put r cos alpha. This is the formula for getting distance along parallel of latitude. But this time around, I don't want to get distance along parallel of latitude. I want to get the shortest distance, because this distance, which is length of arc, is too far. The shortest distance between A and B can just be this particular line here. And this line which I have drawn is a chord. And remember, there is a formula that is used in getting length of a chord. Length of chord is equivalent to 2r sine theta all over 2. That's the formula you use in getting the length of a chord. Then what is our r? Small r is equal to r cos alpha, as usual. So here I'm seeing r, I'll put r cos alpha. Hence, length of chord, which is the shortest distance, will now be 2. Seeing this small r, I'll put r cos alpha, then sine theta all over 2. That's the formula you use. Okay, so with this formula, we can now get the shortest distance between A and B. And what is my R? Capital R is the radius of the Earth, which is around 6,400 kilometers, times cos alpha. I told you that alpha is 30 degrees. Okay, then times sine theta over 2. My theta is 75 degrees, so it's gonna be 75 degrees all over 2. So this whole thing becomes 2 times 6,400 times cos 30 degrees, then times sine 37.5. Because if I divide 75 by 2, I will get 37.5. So without wasting time, let me just use calculator and compute the distance. 2 times 6,400 times cosine of 30 degrees times sine 37.5. This will give me around 6,748.2 kilometers approximately. So you've now seen how you can get the shortest distance between 2 points. Thank you so much.